Okay, so today we're going to look over synthesis reactions, and I sent out a worksheet to you guys with some examples. So as you can see, we have worksheet number 2, synthesis reactions, and if you scroll down, you're going to get your answers. Okay, I will let you know that any synthesis where it is 2 compounds, which is not on here. Actually, I lied, it is on here, number 3. You will not have to do that unless, as you can see here in number 3, they give you what the product's going to be, because that's not something you know yet at our level of chemistry. In something like number 2, if you have a transition metal, they have to tell you the charge. So this is copper 2. Okay, so I'm going to work through the first one with you. We have calcium and oxygen. So over here on our paper, we look up the symbol for calcium. It's Ca, plus oxygen is O. And then in your brain, when you see that you're writing down oxygen all by itself, you should remember that it's diatomic, so you have to give it a number 2. Over here on the right-hand side, we know we're going to put down calcium. We know we're going to put down oxygen. Synthesis means we take all the small pieces and we shove them together into one big compound. However, we have to check charges and swap and drop. So calcium is plus 2 when I look it up on the periodic table. Oxygen is minus 2 when I look it up on the periodic table. Therefore, they cancel each other out. Okay, we don't have to worry about swapping and dropping. Okay, now we look at the equation now that we made our compound, and we check to see if it needs to be balanced. Okay, you don't want to leave your charges in your final equation. Okay, so I make my chart. I have calcium. I have 1 on the left. I have 1 on the right. I have oxygen. I have 2 on the left. I only have 1 on the right. Okay, oxygen is the only thing I have to balance. So in order to balance that, I'm going to put a big number 2 out front here in front of the calcium oxide. That now, though, is going to give me 2 times my 1 calcium, which gives me 2 calcium. 2 times my 1 oxygen gives me 2 oxygens. So now I look at my chart, my oxygens are now balanced. However, my calciums are not. I have 2 calciums on the right. I only have 1 on the left. So in order to balance this, I'm going to put a big number 2 over here in front of my calcium. 2 times my 1 calcium now gives me a total of 2 calciums. So I have 2 calciums on the left, 2 on the right, 2 oxygens on the left, 2 oxygens on the right. Okay, let's try number 2. Number 2 is copper 2 plus sulfide. So I have copper all by itself plus sulfur. When you write sulfur by itself, a bell should be going off saying, oh wait, sulfur can't be by itself, it's S8. We draw our arrow. We have copper, which is positive 2, coming together with sulfur, which happens to be negative 2. Okay, so this is positive 2, that's negative 2 on the equation. Okay, on the periodic table. So therefore, those charges cancel out. So we don't need to swap and drop. However, we obviously need to balance. So we have copper, 1 on both sides. We have sulfur. We have 8 on the left and only 1 on the right. So in order to balance, I'm going to put in 8 in front of my copper sulfide. 8 times my 1 copper gives me 8 copper. 8 times my 1 sulfur gives me 8 sulfur. My sulfur is now balanced, however, my copper is not. I have 8 copper on the right. I need to have 8 copper on the left. Okay, I'm going to pop down and do number 4. We have hydrogen, which cannot be by itself, so you better give it a 2. Plus, we have nitrogen, which also cannot be by itself, so we're going to give it a 2. Over on the right-hand side, we know nitrogen and hydrogen are going to be coming together. So we have hydrogen, which has a positive 1 charge. We have nitrogen, which has a minus 3 charge. We have to swap and drop. So the nitrogen gives the 3 to the hydrogen and the 1 from the hydrogen goes over here to nitrogen. Remember, you can also think of it as a least common multiple. So the least common multiple between 1 and 3 is 3. Sorry. So if I want to have a positive 3 charge over here on the hydrogen, I need 3 of them. If I want to have a negative 3 over here on the nitrogen, I only need 1 of them. So let me erase that. Okay, now we're looking at balancing now that we have our compound together. On the back, you will notice that this is written the other way because it's a covalent bond. So I'm just going to rewrite this. This is not one you would have on our test where you would get it wrong if the nitrogen was listed first or second. Okay, so just because it's a covalent bond, the hydrogen goes second. Don't worry about that. If I just stressed you out, do not rewrite it on your paper. You are fine. Okay, I just have to have it that way because that's the proper way to have it. Okay, so hydrogen on the left, I have 2. On the right, I have 3. Nitrogen on the left, I have 2. On the right, I only have 1. Okay, in this case, I cannot just pick an easy number to multiply on either side so that I have the right amount of things. So I'm going to start with the hydrogen. I know we're normally supposed to start with the nitrogen, but you really got to think the hydrogen out here. Okay, so if I have 2 hydrogens on the left and I have 3 on the right, my best course of action is to go least common multiple. Okay, I don't always have to use least common multiple, but in this case, it really works out. So the least common multiple between 3 and 2 is 6. So if I want to have 6 hydrogens on the right, I'm going to multiply this compound by 2. 2 times my 1 nitrogen gives me 2 nitrogens. 2 times my 3 hydrogens gives me 6 hydrogens. Take a look, my nitrogens balanced each other out. So if you would have put your nitrogen first and balanced that, you still would have ended up with 6 hydrogen, and therefore coming over here and telling me that in order to balance my hydrogens, I need to put a 3 in front. So 3 times my 2 hydrogens gives me a total of 6 hydrogens. All right, guys, that's it. I hope that helps. Good luck, and make sure you're writing me if you have any questions.